Hello everyone. I think you remember in the last session we end with the package, right? Air cooled and water cooled package. We have some more system to discuss to deal or to complete this chapter 5. So the next system is VRF or VRV. We'll discuss in detail. Apart from this, in this chapter, you'll find geothermal system, district cooling, and the very important chill water system. So let me proceed with the VRF. You see, in short, we used to call VRF or VRV. It's a variable refrigerant flow or variable refrigerant volume. And this comes under DX system. DX nothing but direct expansion. What exactly DX? I'll give you the idea after this topic. At this level, remember DX system means the refrigerant is responsible to cool the air compared with the chill water system. So VRF also comes under DX system. And in VRF, if you compare this VRF with the split system, the major difference is, you know, this in a split AC or inductible split, you can connect one indoor to one outdoor. But in case of VRF or VRV, we have option to connect multiple indoors to one outdoor. You can find on screen also on the left side image. You see, consider this as one outdoor, one unit, and to which we can connect different types, multiple indoor, nothing but FCU or AHU. You see, these are all FCUs. And below we can call this is AHU, this is concealed AHU, and this is a cassette. So first point is with one outdoor, we can connect to multiple indoors. And the second point is the indoor can be of different types, which suits the interior requirement or the site condition. So we have a lot of flexibility in this. As per the interior requirement, if they ask for cassette or high wall or freestand or concealed FCU or a ducted AHU, we can use any of this type. Now, so we'll discuss more about this. This is interesting and important. And in present market, this is becoming popular in India, in Gulf, or in many regions, because we have a different types also in this. So what are the different types and how the system works and how we can save the energy in this compared with the normal split system? All these points we'll discuss in this session. So you see, VRF in short is a variable refrigerant flow, or VRV, variable refrigerant volume, are both HVAC technology used in commercial and residential building for efficient temperature control. And don't get confused, technology point of view, VRF and VRV both are same. Then why we are using the different name? Here you'll get the answer for this. The VRF name is patented by Daikin. And this technology is originally from Daikin, from Japan. And they introduced this in, I think, 1982. Okay. And they have given the name as VRF. So that's the reason they have a patent for this name. So other manufacturer cannot use this. So that's the reason other manufacturers, they're using this term as VRF. So technology point of view, both are same. Make to make, you'll find some difference, some additional options, additional features, etc. But concept point of view, VRF or VRV, both are same. Don't get confused. So what I explained the same, one outdoor can connect to multiple indoors of different types with the different capacities and how it can be done, how the system works. We'll discuss in detail. Let me complete this, some theory first. So here you see, next some important points before moving to the different types of VRF. In VRF also you'll find the different three types. We'll discuss in detail. Some important points you can find on the screen. As I explained just now, VRV is patented by Daikin. So other manufacturer, they can use the term as VRF. Okay, technology point of view, both are same. And you see, one outdoor can connect to more than 60 indoors of different types of FCU or AHU. Okay, FCU can be concealed FCU, it can be a decorative FCU, or it can be floor mounted AHU, or it can be a ceiling suspended AHU. So don't worry, at this level, we have not discussed in detail about FCU and AHU. No? We have a separate topic, but you see on screen, this is AHU. These are all AHU on the right three, and above all is, including this cassette, is FCU. These are the different types of indoor unit. Okay, but we have some different based on the capacity and based on some features that we'll discuss. We have a separate topic before moving to the still water system. Next, you see 60 or more than that depend on the make and the location. Some manufacturer they're offering up to 20, some are offering there up to 60 or up to 65. Some makes depend, and the numbers may increase as per the improving the technology. But in the market, most commonly is available up to 60 indoors. Next type of compressor. This is
Sir,
important.
it depends on capacity or number of indoor units.
You see, capacity we have in that capacity only we need to match that one. Okay, and we have a capacity in general up to 40 or 42 TR. Okay, in that you need to match the indoors. Don't worry, don't do the conclusion. But we have a possibility to connect to up to 60 indoors, but definitely as per the capacity of outdoor. If the outdoor capacity is say 20 TR, so we cannot connect more than 20 indoor or 1 TR, right? So in that way. Next, you see type of compressor. This is also important in VRF. Not only in VRF, now in market, even in split system, or even in chill water system, you'll find this type of compressor. But mostly the inverter compressor or digital compressor start with the VRF system. Now it's available in the split system also. So you see type of compressor you use in VRF. When I use the term VRF means include that VRV also. Okay, repeatedly I'll not use both the terms. VRF means by default with the VRV. So the type of compressor, one is a digital scroll compressor and the second is a inverter scroll compressor. And as a mechanical, you know the different types of compressor, no? Screw compressor, scroll compressor, reciprocating compressor, etc. But remember in VRF, we are using scroll type. And even in split system with the inverter type, you'll find scroll. And now in many vendors, even in split, they are using the scroll because the noise point of view or efficiency point of view, we have advantages. So as a mechanical, I believe you know what is scroll compressor, right? Again in scroll, we have digital scroll. So digital scroll means it will engage or disengage like in four-wheeler, we have a clutch. The clutch is used to engage and disengage the engine from the transmission. Similarly, in digital scroll compressor, just I'm giving the idea. If you want more, you can just watch the video after the session because for everything I cannot go in the detail. I mean, that is not required also. So digital compressor concept is it uses engage and disengage concept as per the load requirement. Okay, but the type is scroll only. An inverter scroll compressor, you'll find this variation in speed. The inverter scroll compressor can run with the different speed because this work with the VFD drive. Okay, so what is VFD? You'll find in the next only, and very important concept, not only for compressor. VFD concept is important for the pump as well as for the fan also in the HVAC. So I'll try to give the idea of the VFD, this VFD, variable frequency drives. So inverter scroll compressor is a scroll compressor, but it can run with the different speed as per the load demand. If the load reduces, the RPM of the scroll compressor decreases. If the load increases, the RPM of that scroll compressor increases because this is connect with the VFD drive. So how exactly VFD? You'll find in the next only. Next, you see the type of refrigerant commonly used in VRF system. May ask in interview. 410A or 407C, R32 or R454B, and all belongs to HFC category, hydrofluorocarbon. You know what is HFC. Next, this is also important point to discuss. You know this in a split system, the maximum length of the pipe in between indoor to outdoor. We discussed now 25 to 30 feet. Or some manufacturer as per the capacity, it may up to 15 meters. 15 meters nearly 45 feet. And that depend on capacity because if you talk about the split cassette type with 4 TR, because splits available up to 4 TR, no? With the 4 TR, the length of the pipe also you may get up to 45 feet, nothing but 15 meters. So the limit for the split is what? 15 meters. That too as per the capacity, not for all. For 1.5 to 2.5 TR, you may get 25 to 30, not more than that. But in case of this VRF system, you see the limit is up to 150 meters. But in this also we have points to discuss. 150 meter on what case? If the outdoor and all the indoors which is connected at the same level, means suppose the building is of only ground floor and the outdoor unit is on the roof, means that this is almost with the same level, the outdoor unit and the indoor units with the same level, so we can go up to 150 meters. This is in general. Again, this may vary from make to make. This is most manufacturers, they are offering this. This is the first point. Second point, if the outdoor unit is, you see, above and the indoor unit is below, suppose the outdoor unit is on the roof and the indoor unit is connected to multiple floors, say 5-floor building or 7-floor building, in that case the limit is 50 meters. And if it is reverse, for example, this is outdoor and this is indoor, the indoor is above, the suppose outdoor is placed on the ground level and it's connected to multiple indoor on different floors, you see outdoor unit below indoor, in that case we have 40 meters. Okay, so this is in general for interview point of view. Again, you need to refer the manufacturer catalog at the time of pipe sizing, and we have a separate topic of pipe sizing for the VRF using the catalog from the vendor, or we have softwares also, because this is a precise or precision type of machine compared with the other type. So this guideline, remember, may ask an interview. Next point, you see 30 to 40% power saving or energy saving compared with the normal compressor split system. Again, as I said, in a split system also you'll find this inverter type scroll compressor. In that case, you'll find very close power saving. But if you talk about the normal compressor split system, in that case, you can expect 30 to 40% saving of energy. Okay, and that's the reason now even from LG or from Carrier, from many brands, for in split system, they are offering inverter technology. And you know this power saving, 3-star or 5-star rating. And we are getting a very good power saving. So even a middle class family also can afford this because they can able to pay the running bills compared with the 5 years or 10 years back because of this technology. Next, you see inverter compressor RPM change as per the load demand, what we discuss. Why? Because it uses VFD drive, variable frequency compressor. So what is VFD? We'll discuss now. So remember, we have this term VFD and VSD. VFD is a variable frequency drive and VSD is a variable speed drive. And remember, by default, VFD is also VSD. Means if the pump, compressor or a fan, remember this technology is for all means for compressor, for pump or for fan. Pump means I'm talking about the chill water pump or condenser pump, we'll discuss. And fan you'll find in the AHU, you'll find in the FCU. In that also you'll find this technology, especially in the AHU for power saving. So remember, if you find this VFD technology, it means by default it's a VSD. So variable frequency means as the frequency, and frequency means I'm talking about the power frequency. Okay. And for in Indian market, the power frequency is 50 hertz, and in US it's around 60 hertz. So this frequency will change. So remember, variable frequency drive means I'm talking about the frequency of the power supply. So if you change the frequency of power supply to a pump or to a compressor or to a fan motor, at this level, take example of compressor. So what will happen? The RPM of that also change accordingly. And you can find the point here. You see power frequency is directly proportional to the compressor speed. In case of compressor, you can add pump or fan also. Okay, so as the power frequency changes, the speed of the compressor also changes. As the frequency increases, 1 minute. As the frequency increases, the power, this RPM of that compressor also increases. As the frequency decreases, it will also decrease. Okay, and this is VFD. I'll give you more points related to it. But first of all, you see, if the system is only VSD, it means it can change the speed without changing the power consumption. By changing the speed by using the gears or the pulleys, but the motor speed is going to be same. So the motor speed is not changing. We are changing the fan motor speed RPM by changing the size of the pulley or suppose using the gears. In that case, the system is only VSD. There is no change in the power consumption. So remember, VFD means by default it's a VSD, and as the speed decreases, the power frequency means the power consumption also changes. It may increase or decrease. But if the system is only VSD, it means the speed can vary, but the power consumption will not vary. There will be no saving in energy. Take example of a ceiling fan. Ceiling fan I can run with a speed 1, 2, 3, 4, 5. Na? but that ceiling fan, we don't have the VFD drive connected. So the ceiling fan, we can say, is a VSD, variable speed drive, but not the variable frequency drive. The power consumption in all the speeds is going to be same. So remember, power frequency changes, then the speed of that compressor also will change. And the same concept applicable for pump and fan. And why I'm adding this pump and fan? Because this same VFD concept you'll find at the time of pump selection as well as for fan selection. Because in pump, if you talk about secondary pump, the secondary pump is a variable, this variable speed pumps. Okay, and even in VAV system, the fan motors are variable speed drives, nothing but with a VFD drive. Okay, so this concept is important. So you see, a variable frequency drive, VFD, is an electronic device used to control the speed and torque of an electronic motor. And this can be achieved by varying the frequency and voltage supply to the motor. What you asked just now. VFD are commonly used in industrial and commercial appliances to improve the efficiency, energy efficiency, and now in market in HVAC, plumbing, not commonly in firefighting, because firefighting we are not talking about running cost. In plumbing also you'll find this concept for the pumps to save the energy. So how exactly? You see, actually this VFD concept belongs to electrical side, but as a mechanical we are using in application side.
Yes.
At least you should have some basic idea. So I'll play one video. You'll get some more idea about this VFD.
So what exactly is a VFD? Well, it stands for Variable Frequency Drive. They are used for running an AC motor at variable speeds, or let them ramp up their speed to give them a smooth startup.
You see, for example, at this level, we are talking about VRF now. So you can consider, instead of motor, you can consider this as pump. Sorry, this is compressor.
Some people simply call them drives. They work by adjusting the frequency of the motor to adjust the RPMs. To do this, a VFD will actually convert the voltage twice. First, it converts our three-phase AC to DC. This is accomplished with diodes. Then it cleans the DC with a capacitor. Next, it will convert the DC to AC. This is accomplished with transistors acting as switches. Utilizing these switches is what allows the VFD to adjust the frequency that the VFD supplies to the motor. This in turn controls the speed of the motor. Now, I know this is a lot of information to take in. Let me compare the internal workings of the VFD with a simple plumbing system. First, let's look at the diodes that convert the AC to DC. This operates like a check valve in a water system. A check valve, like a diode with electricity, only allows water to flow in one direction. The capacitor acts as a water filter to keep everything clean and usable. The transistors act like valves. They turn the flow on and off when needed. This allows the VFD to adjust the frequency of the motor. Now that we have an understanding of how a VFD works, let's see what they're used for. One very common use in industry is to control the speed of a water pump in a water treatment facility. A water treatment plant typically has a constant flow of water coming into the plant. However, if the water demand exiting the plant is lower than the supply entering the plant, then the operator will need to slow down the supply. This is achieved by using a VFD on the AC motor. The operator can monitor water flow and manually adjust the VFD accordingly. Another great thing about VFDs is the fact that they can be controlled with a PLC. Using basic communication protocols that have been covered in previous videos, such as RS-232 and RS-485, PLCs can monitor and control motor speeds using the VFD. This helps make a process like water treatment that much easier and more efficient. This setup can be used in any situation that would benefit from automation. Let's look back at what we now know. VFD stands for Variable Frequency Drive. They are used for controlling the speed of an AC motor. They are also used for ramping up a motor for a smooth startup, or to prevent a heavy load from straining the motor on startup. This is accomplished by adjusting the frequency delivered to the motor. a setup of an AC to DC converter, then DC to AC converter. VFDs are used throughout industry. A common example is to regulate water flow entering a water treatment plant. VFDs allow the operator to control the flow of the pump manually or automatically with a PLC. There are many different brands and features available. If you're looking at using a VFD,
so I think you got the idea about this VFD. You see, if you go into the basics, it's a very lengthy calculation and the concept that is not required for a mechanical. So what we need, only the concept. So how this frequency change with the power, with the current, with the voltage, we have a lot of relations between that. Okay, so if you want, you can just refer any book, but that much is not required for a mechanical. As a mechanical, for this system, we are interested for the concept. Okay, so the concept is we are changing the frequency to reduce, to change the speed of compressor at this level to reduce or to to save the energy. That's it. But a lot of things are involved in this. So this part we are using in this VRF system. Let me proceed. Next. You see, these are the basic to learn the VRF system. Okay, what I explain. So the first point is what? One outdoor, multiple indoors, and the compressor is of scroll, inverter scroll, or it can be a digital scroll. Digital scroll, not in all the make. Most commonly you'll find inverter scroll compressor. In some makes you'll find the digital type also. Digital concept is just engaging and disengaging the compressor with the load, like clutch we are using in the transmission in the four-wheeler. So this also one type, but commonly you'll find inverter scroll compressor that works with the VFD.